Okay, so given the force 100 Newton and acceleration which is 0.30 meter per square second, we are required to solve for the mass in kilograms. So very easy class, a very easy problem that we have. So using the formula of the Newton's second law of motion, so force is equal to mass times the acceleration. So since our units are already in the SI unit, so we can directly substitute our value. So 100 Newton is equal to mass, which is our unknown, times your acceleration 0.30 meters per square second. So simply divide your 100 Newton, or if you could recall, 100 Newton is this is kilogram meter per square second divided by your 0.3 meters per square second. So obviously this will be cancelled out and we will be left with kilogram. And from this, the value is 100 divided 0.3 is 333.333, and the unit is kilogram. Simple as that. So based from this, 100 Newton, so times, you have 4.448. I'm sorry about my ballpoint. Newton in 1 pound force. Okay, so this will be cancelled out. So you'll have 100 divide 4.448. You'll have 22.482 pound force. Okay, while for your acceleration, so we have 0.30 meters per square second. So all you have to convert is the meters to feet. So recall that 1 meter, there are 3.28 feet. Okay, so 0.30 times 3.28 will have 0.984. So 0.984 feet per square second. So using our second law of motion, so force is mass times acceleration. So mass is simply force divided acceleration. So we have a force here of 22.482 pound force all over your acceleration 0.984 feet per square second. So mass is 22.482 over 0.984. There. We have 22.848. And the unit, of course, is already slugs because pound per feet square second is slug. For this problem, so given mass and volume, we are asked for the density. So very simple solution. So density is simply mass over volume. So since both of them are in standard units, so we simply substitute it. So 500 kilograms over 0.513 cubic meter. So you'll have 500 over 0.513. You'll have 974.659, and the unit is kilogram, and that's the answer. Okay, so in this problem class, take note that given 500 kilograms but a different value of volume. Take note, earlier that was 0.315, yeah. In this case, 513, I'm sorry, that was 0.513. Well, this one is 0.135. So in this case, we are to solve for the specific weight. So recall that specific weight can be solved using the density, which is specific weight over the acceleration due to gravity. So you'll be able to solve for the specific weight by multiplying the density to the acceleration due to gravity. So we have first to solve for the density, which is what? Mass over volume times the G. So substituting here, you'll have 500 kilograms over 0.135 cubic meter times your acceleration due to gravity, which is 9.81 meter per square second. Okay? And that would be your specific weight, which is from your calculator, that is 500 over 0.135 times 9.81. There. So that is 333.333, and what will be the unit here? The unit will be, this is Newton per cubic meter, because kilogram meter per square second is Newton, so divided by cubic meter, so Newton, or in your choice, that is 36.333 kilo Newton meters per cubic meter. Okay, so your density here is mass over volume, so divided by the value of the density of water. So the given density of water is how much? That is 1,000 kilogram per cubic meter. So 1,000 kilogram per cubic meter. So substituting here the mass and the volume. So in this case, we have 500.513 cubic meter, and this is kilogram. There, is it clear there? 500 over 0.513. So this will be cancelled out. I'm sorry, this will be cancelled out, so you will not have a unit, or this is dimensionless. So 500 over 0.513 equals, so you divide that by 1,000, so you'll have 0.975 there. And that is your answer. Or you can use also this one using your PG all over. Your value of specific weight is 9.79 kilonewton, or you can use the class 9790 Newton per cubic meter. Okay, you can use that. The same answer will come up. Okay, so we are given here the specific volume, and we are required to solve for the specific weight. So if you could recall, specific volume is the reciprocal of your density, right? That's density. So since we are trying to solve for the specific weight, recall that specific weight over your acceleration due to gravity. So substituting class, we will have 1 over specific weight over g, or this is g over your specific weight. So therefore, to solve for the specific weight, so you simply divide your acceleration due to gravity by your specific volume. So substituting class, as you can observe, the unit is in British engineering, so the value of our g will be 32.2 feet per square second divided by your specific volume per slugs. Okay, so from that, the value is 32.2 over 306, and that is 0.105. Okay, so that's the answer. Okay, so in this problem, so we are given the pressure 150 psi and a volume which is 15 cubic foot. Now take note, class, that the given here is the volume reduction. Take note. So which means it is already the amount that has decreased or have changed from our initial volume, which is the 15 cubic foot. So from the term reduction, so it means that the volume is a negative. Okay, which is 0.02 cubic foot. So we are to determine the value of your bulk modulus of elasticity, and to solve that, so we have a negative what's the formula? P all over dv all over v. Actually the negative is right here, so substituting class, 150 psi. Take note that it is psi. You don't have to convert that because the volume here will be cancelled out. So 15 cubic foot over negative 0.02, negative 0.02 cubic foot. And as you can see, we can cancel out this one, and from that we'll be able to have 150 over negative 15 over negative 0.02 there, and we'll have 0.2. Is it correct? Wait. No, I'm sorry. Mali yung pagka-substitute ko, I'm sorry. It should be negative 0.02 cubic foot all over 15 cubic foot. I'm sorry for that. 150 over negative times negative 0.02 over 15. We'll have 112,500. Of course, the unit will be in PSI. And that's it. That's the solution. Okay, so in this problem, we are given the temperature, which is 90° Fahrenheit, a pressure of 40 psi. This is absolute, and we are given the specific weight, which is 0.0788 pound per cubic foot. So in this problem, class, we are asked to solve for the gas constant. If you could recall, the equation of the state is equal to the gas constant is equal to pressure times your volume per unit weight all over your temperature. Okay, but remember that the values that should be substituted here should be absolute values. So your temperature should be in Rankine. Your specific weight, it should be converted first, or it should be expressed in here in the specific, or rather in the volume per unit weight, because we don't need this specific weight, but rather the volume per unit weight, as well as your pressure should be absolute also, but we don't have to convert it because it's already absolute. So to convert our Fahrenheit to Rankine, so all we have to do is add 460, and that is 550. So we have 550 Rankine. Okay, so we have to substitute it here. So pressure is 40 psi. How about for your volume per unit weight? So recall that specific weight is the reciprocal of your volume per unit weight. So therefore, in order to solve for the volume per unit weight, all you have to do is reciprocate your specific weight, which is 1 over 0.0788. Okay, so in this case, substituting here, we have 1 over 0.0788, and we have our temperature, which is 550 degree Rankine. By the way, our unit here is reciprocal of this, cubic foot over pound. So we have cubic foot over pound. But take note, class, in order for us to cancel things out, we have to convert first our PSI into pound per square foot. Okay, so let us convert first 40 PSI, or this is pound per square inch. So we have to convert it 12 inches in 1 foot, and you have to square that in order to cancel this thing. So 40 times 144, that is 5760. 5760. The unit is pound per square foot. So I will change it here, class. Why are we converting it? It's because we cannot cancel things out later. There. So from here, you'll be able to cancel square foot. So what will be remain here is only foot. Pound will be cancelled. So therefore, the unit here is feet over degree Rankine. So the unit or the value is what? So we have 5760 times 1 over 0.0788 there, and 550. So the answer is 132.903. And that's the answer, class, for your gas constant.